Okay, I want to use the given graph of the function to answer parts A through N. First up, the function at 0 is at 3. It's the y value when x is 0. The function at -6 is a -3. It's the y value when x is -6. The function at 6 is 0. The y value when x is 6. The function at 11 is 1. F of 3 is positive. And f of -4 is negative, below the x-axis. What values of x is the function equal to 0 at? It's where you hit the x-axis at. At -3, at 6, and at 10. For what values of x is the function positive in between -3 and 6, and after 10, from 10 to 11. What's the domain of the function? It goes from -6 to 11. All the possible x values. What's the range of the function? The possible y values, you go from -3 up to 4. What are the x-intercepts? That's the same as the answer to E. What is the y-intercept? There's only one, if there is one, and that is the point 0, 3. It hits the y-axis at 3. How often does the line y equals half intersect the graph? 1, 2, maybe 3 times? Yeah, 3 times. How often does the line x equals 5 intersect the graph? X equals better only intersect once. Yeah. For what values of x does the function equal 3? X equals 0 and x equals 4. For what values of x does the function equal -2? X equals -5 and x equals 8. Find the domain and range. Domain possible x values, you go from -infinity up to -1. We get to include -1, and we go from 1 out to infinity. These are the possible x values. The possible y values, these arrows indicate that you go up and down forever, so that's the domain, what we just did. And the range is going to be all y values from -infinity to infinity. Any symmetry with respect to the x-axis? Yes. Y-axis? Yes. Origin? Yes. Number 13, domain would be -pi up to pi, including. The range would be -1 up to 1, including. You include if you have it. You don't include if you can't equal it. You can never equal infinity or negative infinity, so I always use parentheses for those. The intercepts. Well, I didn't answer the intercepts question here. Sorry. Domain and range, symmetry. The intercepts question. X-intercepts for this question is -1 and 1, and there is no Y-intercept. X-intercepts, -pi/2 and pi/2. And the Y-intercept is 1. Symmetry, we have Y-axis symmetry only. It's a mirror image across the Y-axis. But no X-axis symmetry and no origin symmetry. Okay, then we have 15. The domain would be -infinity up to 0, including 0. And the range would be -infinity to infinity. But the indication of this arrow means it would continue to go down and continue to go up. Intercepts, the origin is the X and Y intercept. And symmetry, just X-axis symmetry. No Y-axis symmetry, no origin symmetry. No mirror image across the Y-axis and no mirror across the origin. 17. Domain would be 0 to infinity, not including 0, because of the way that it asymptotically goes down, like an asymptote. It's called an asymptote, where you go down and this pattern continues. You get closer and closer to 0, but you never quite get to x equals 0. And the range is going to be all real numbers. These arrows tell you that goes on forever up and forever down. There is an X-intercept at 1. There is no Y-intercept. And there is no symmetry. No X-axis symmetry, no Y-axis symmetry, no origin symmetry. Okay, and then 19, we have the domain being -infinity to infinity. We get to use all real numbers there, but the range is not. The range is going to go from -infinity up to 2, include 2. That's the highest Y value that you get. Intercepts, there's 2 X-intercepts at -3 and 3. There is a Y-intercept at 2. Symmetry, we have Y-axis symmetry. It's a mirror image across the Y-axis. Okay, 21. Domain would be all real numbers, -infinity to infinity. We're allowed to use all. This thing goes on and continues on in that direction. This thing goes on. We continue on in that direction. And it's a polynomial. It's a parabola. You get to use everything. There's nothing restrictive there. And the range, we get a low point of -3 and then a high point. It goes on forever to infinity. The intercepts, there's an X-intercept of 1 and 3. And it looks like there's a Y-intercept of 9. And there is no symmetry because it's been altered. The parabola has been shifted over, so the symmetry that it would have had is gone with the y-axis. Alright, 23. Letter A, parabola 2x squared minus x minus 1 is the point negative 1, 2 on the graph. If x is negative 1, then y is 2 plus 1 minus 1. The y value is 2. So the answer to this question is yes. Letter B. If x is negative 2, what's y? Y will be 2 times 4 plus 2 minus 1, which is 9. What point is on the graph of the function? The point is negative 2, 9. Letter C. F of x is negative 1. Oh no, yeah, that's saying y is negative 1. Go out and get x. And so 2x squared minus x minus 1 is equal to negative 1. And so by adding 1 over, we get 0. These guys cancel. We get 2x squared minus x is 0. Take out an x and have 2x minus 1 is 0. So either x is 0 or 2x minus 1 is 0. That says that x is a half. So there's two values. We have the point 1/2 negative 1 and the point 0 negative 1. Okay, letter D. What's the domain? It's a polynomial, so it's a parabola even, so all real numbers. List the X-intercepts, if any. That's when y is equal to 0. If x is 0, then y is negative 1. And if y is 0, there's possibly two x's. 2x squared minus x minus 1 is 0. This factors, hopefully, to 2x and 1 with a minus and a plus. I think, yes. And so either x is 1 by setting that one equals 0, or x is negative 1/2 by setting that one equal to 0. So for letter E, we have the y-intercept. That's letter F. And for letter E, we're going to have negative 1/2 and 0, 1 and 0. These are the X-intercepts. Okay, great. The second function here, 25, we have if x is 3 plus 2 over 3 minus 6, that's not 14, so no. If x is 4 plus 2 over 4 minus 6 is 6 over negative 2, which is negative 3, and the point is 4, negative 3. And the answer is yes. Oh wait, what is, okay, y is equal to the, sorry, then I'm asking, is it they're saying y is equal to negative 3, and they want to know what the, when the x is 4, what's y? We just told them it was negative 3, and there's the point. Letter C, if x is 2, so we have, no, f of x is 2, sorry, I didn't see that. F of x is 2, so we set f equal to 2. So we have x plus 2 over x minus 6 all equals to 2. We cross multiply, we get x plus 2 is 2 times the quantity x minus 6. Distributing, you get 2x minus 12. If we take away x and add on 12, we get that x is 14. So when y is 2, x is 14, that's the point on the graph. The domain, you can have division by 0, so you want to avoid that. And so if x minus 6 is 0, that means x is 6. So we have, as a domain, everything but 6. We go from negative infinity up to 6, and we go from 6 up to infinity. We say all real numbers except 6. Okay, and then lastly, letter F. Oh no, E and F. E is the X-intercepts. That's when y is equal to 0. Let me first do F. F is easier. If x is 0, what's the y? And if x is 0, we get 2 over negative 6. So that'd be negative 1/3. That's the that's the y-intercept. That's the answer to F. That's the y-intercept, if we put it as a point. And then the x-intercept is a little more complicated. We have to set y equal to 0, but it's a fraction. It's x plus 2 over x minus 6. So we just multiply everything by x minus 6, and we end up with 0 is x plus 2. It's a fraction when its numerator is 0, and that's at negative 2. So if y is 0, x is negative 2, and that's the x-intercept. There's only one. Okay, and then finally, last number 27. If x is negative 1, the y is 2 over 1 plus 1, which is 1. So yes, that's on the graph. If x is 2, y is 2 times 4 over 16 plus 1, 8/17. And the point on the graph is 2 and 8/17. Sorry, that's a 7. Letter C, if y is 1, find x. This is going to be difficult. We cross multiply. We get x to the 4th plus 1 is equal to 2x squared, or x to the 4th minus 2x squared plus the 1 is equal to 0. And this is a quadratic looking. If it was w squared minus 2w plus 1, we would say w minus 1 and w minus 1. That's what we have here. We have x squared minus 1 and x squared minus 1. Okay. And so x is plus or minus 1. So the points on the graph would be 1, 1, and minus 1, 1. Letter D, what's the domain? Well, you have denominator, so you have to worry about division by 0, but x to the 4th plus 1 is never 0. Why is that? Well, x to the 4th is always positive, and you're going to add 1 to a positive number, it'll always be positive. So there's nothing to give you division by 0, so your domain is all real numbers. Or if you want to say it with minus infinity to infinity, that works too. Letter E, the x and y intercepts, let's do E and F together. X and y, if x is 0, that's the easier one to do, then y is 0. So that's the x-intercept, and I believe that's also going to be the y-intercept. Whenever you have the origin as an x-intercept, it's it's going to be the same as for the Y-intercept. So the origin is the X and Y intercept. And we're done.